Important questions of complex number. 2 marks question. Okay. First question. Write the multiplicative inverse of complex number 7, 24. Solution. We have one formula for multiplicative inverse of complex number, that is a by a square plus b square comma minus b by a square plus b square. Okay. A and b is nothing but this point. This is a and this is b. A is 7, b is 24. Okay. 7 by 7 square plus 24 square minus 24, that is b value, upon 7 square plus 24 square. Just we have to substitute a and b value in this formula. 7 by 7 square is 49 plus 24 square is 576 minus 24. 7 square is 49, 24 square is 576. Denominator is same. Okay, 7 by adding these two you will get 625 minus 24 by 625 is the multiplicative inverse. Second question, write the complex number 2 minus 3i, 3 plus 4i in the form of a plus ib. Okay, it is in product form, so we have to multiply this first. Okay, 2 into 3 is 6, 2 4s are 8. First multiply with this 6 plus 2 4s are 8i minus 3 3s are 9, I 9i plus into minus minus 3 4s are 12, I into I is I square. Okay, 6 9 minus 9i plus 8i is nothing but minus 1i, that is I. Okay, minus 12, I square value is nothing but minus 1. So minus 12 into minus 1 is nothing but plus 12. 6 plus 12 is 18, 18 minus I. Now we have to write this in this form. Okay, so we want plus value here. 18 plus I, here minus 1 is there, so writing minus 1 in the bracket, that is a plus ib. Question number 3. Write the complex number 1 minus 2i whole cube in the form of a plus ib. Same as above, but here it is in the form of a minus b whole cube. Okay, here we have to apply this formula, a minus b whole cube formula, that is nothing but a cube minus b cube minus 3a square b plus 3ab square. Okay, a is 1 and b is 2i. A cube minus b cube minus 3a square b plus 3ab square. Okay, 1 cube is nothing but 1 minus 2 cube is 8, 2 into 2 into 2 is 8, and I cube same as it is minus 3 into 1 square is nothing but 1, 3 ones are 3 into 2i plus 3 ones are 3 into 2 square is 4, 4 into I square. Okay, 1 minus 8 I cube minus 3 2s are 6i plus 3 4s are 12. I square value is minus 1. So multiplying 12 with minus 1. Okay, 1 minus 8 I cube is nothing but minus I. See here, we can write I cube as I square into I. Here power is 1, bases are same, power should be added. 2 plus 1 is 3. So we can write I cube as I square into I, because we know the value of I square, that is minus 1. Minus 1 into I is nothing but minus I. So at the place of I cube we can write minus I. Minus 6i same as it is, plus into minus minus 12. 1 minus into minus plus 8i minus 6i minus 12. Here these two are I terms, so we can simplify. Plus 8 and minus 6 is nothing but 2i. Minus 12 plus 1 is minus 11. So now we have to write this in this form. So first number, that is 11 minus 11 plus then imaginary part. This is real part and this is imaginary part. Plus I into 2. A plus IB. Question number 4. Find the modulus and the principal amplitude of the complex number minus 1 minus root 3i. Okay. It is in the form of x plus iy. Minus 1 minus I root 3. This is our question. Okay. X is minus 1 and I coefficient is y. So here I coefficient is minus root 3. So y is nothing but minus root 3. So we can write minus 1 comma minus root 3. They both are x and y. Both are negative. So this belongs to quadrant 3. Okay. Here x comma y belongs to quadrant 3, it's a formula. Okay, whenever the point belongs to quadrant 3, theta is equals to minus pi plus tan inverse of y by x we have to use. Okay, minus pi plus tan inverse y and x is nothing but this is x and this is y. So minus root 3 by minus 1, minus minus gets cancelled. So minus minus gets cancelled. Root 3 by 1 is root 3. Okay, minus pi plus tan inverse, we can write root 3 as tan 60 degree. This is pi by 3 is nothing but 60 degree. Okay, tan 60 is root 3. Tan inverse and tan gets cancel. Minus pi plus pi by 3, take LCM, you will get 3 LCM, multiply 3 here, minus 3 pi plus pi by 3. Minus 3 pi plus pi is nothing but minus 2 pi. Minus 3 plus 1 is minus 2 pi by 3. So theta is equals to minus 2 pi by 3. Now we want r. R is equals to under root x square plus y square. X is minus 1 whole square plus minus root 3 whole square is equals to under root minus 1 square is nothing but plus 1 plus root 3 square is this minus will become plus and this square and root gets cancelled, you will get 3. 1 plus 3 is 4. Root 4 is nothing but 2. So our value is 2. Now amplitude form is nothing but modulus amplitude form is r into cos theta plus I sin theta. So for writing in this form we want r value and theta value. Theta is minus 2 pi by 3 and r is 2. 2 into cos theta is minus 2 pi by 3 plus I sin theta is minus 2 pi by 3. Question number 5. Write the conjugate of the complex number z is equals to 5i pi 7 plus I. Okay. We have to write the z bar. We have to find conjugate of z. Okay. Whenever there is a fraction and I value is in the denominator, so we have to rationalize the denominator. Rationalize is nothing but multiply and divide by the denominator, but by changing the middle sign. If there is plus, there will be minus here. Okay, so 5i by 7 plus I into 7 minus I by 7 minus I. Okay, multiply these two and these two here. 5i into 7 minus I, 7 plus I into 7 minus I in the denominator. Okay, now 5 sevens are 35, 35i minus 5 into I square. Okay, this is a plus b into a minus b form. So we can write it as a square minus b square. A is nothing but 7. So 7 square minus this is b I square. Okay, 35 into I minus 5 into I square values minus 1 upon 7 square is 49 minus I square is minus 1. 35i minus into minus plus 5 ones are 5. 49 minus into minus plus 1 50. So 35i plus 5 by 50. Now giving denominator separately. 35i by 50 plus 5 by 50. Okay, now cancel it. 5 sevens are 5 tens are 5 ones are 5 tens are. Okay, now first writing the real part, that is 1 by 10, then I part, that is imaginary part, I 7 by 10. So z bar is equals to I by 10 plus I 7 by 10 is the question number 6. If z1 is equals to minus 1, z2 is equals to minus I, then find arcs z1 comma z2. Okay, z1 is minus 1, z2 is minus I given. Okay, z1 is equals to minus 1. We will write these in the complex number form. That is, this is number. So write minus 1 plus I term is not there. So we can write it as I into 0. That is nothing but 0 only. So just we want to write in complex number form. Minus 1 plus I into 0. So minus 1 is nothing but cos 180 degree plus I into sin 180 degree. So both the theta value should be same. So it will be same when cos 180 and sin 180 value is 0 and it is minus 1. Okay, cos 180 is minus 1, sin 180 is 0. So arc z1 is equals to theta, that is nothing but theta value is how much? 5. Similarly, we will find for z2. z2 is equals to minus I. Here imaginary value is given and real part is 0. So 0 plus I into minus 1. So cos will be 0 when it is minus pi by 2 and sin will be 1 at sin 90 degrees. Sin 90 is 1. Sin of minus 90 is minus 1. So sin of minus 90 is minus 1. So here also cos of minus 90. Cos 90 is 0, but cos of minus 90 we are writing because here minus is there, so we are writing minus. Anyhow, cos of minus theta is cos theta only. Okay, so cos of minus 90 is sine of minus 90, that is nothing but theta value. Okay, so arc z2 is equals to theta, that is minus pi by 2. Arc z1 comma z2, z1 into z2 is equals to arc z1 plus arc z2. This is the formula for arc z1 z2, which is equal to arc z1 plus arc z2. Arc z1 value is pi plus arc z2 value is minus pi by 2. Pi plus minus pi by 2. Pi plus into minus minus pi by 2. Here fraction is there, so take LCM. LCM will be 2 and these 2 will be multiplied here. 2 pi minus pi by 2. So 2 pi minus pi is nothing but pi by 2 is the answer. Question number 7. If z1 is equals to minus 1, z2 is equals to I, then find arc z1 by z2. Arc z1 by z2 is nothing but arc z1 minus arc z2. So first we have to find these values. These values are nothing but theta values. So first z1 is equals to minus 1. We will write this in the form of complex number. So real part is given minus 1 and imaginary part is not there. So we can write it as I into 0. Okay, so minus 1 means cos 180. Cos 180 will be minus 1. Similarly, sin 180 is 0. So we can write cos pi plus I sin pi. Therefore, arc z1 is equals to pi. Now z2 is equals to I, which is equals to 0 plus I into 1. Imaginary part is given and real part will be 0. So here 1 means, here we have to write sine, here cos. Okay, so sin 90 is 1. Sin pi by 2, that is pi by 2 is 1 and cos pi by 2 is 0. Cos 90 is 0. So we can write it as cos pi by 2 plus I sin pi by 2. Therefore, arc z2 is equals to pi by 2 and arc z1 is equals to pi. Now we will substitute in the formula. Arc z1 by z2 is equals to arc z1 minus arc z2. Arc z1 is pi minus arc z2 is pi by 2. Now take LCM. LCM will be 2 and these 2 will be multiplied here. 2 pi minus pi by 2. 2 pi minus pi is nothing but pi by 2 is the answer. Question number 8. If z is equals to cos theta comma sin theta, then find z minus 1 by z. Okay. First we will write these in a complex form. Z is equals to cos theta plus I sin theta. Cos theta plus I sin theta. We want 1 by z now. 1 by z value is cos theta plus I sin theta. Here the complex number is in denominator, so we will rationalize the denominator. Rationalizing the denominator, 1 by cos theta plus I sin theta into rationalizing nothing but multiplying and dividing by the denominator by changing the middle sign. Cos theta minus I sin theta by cos theta minus I sin theta. Okay. Now multiplying the numerator, cos theta minus I sin theta into 1 is nothing but cos theta minus I sin theta, and multiply the denominator, cos theta plus I sin theta, cos theta minus I sin theta. This one same as it is, and this is in the form of a plus b into a minus b, that is nothing but a square minus b square. So a is cos theta and b is I sin theta. Cos square theta minus I sin theta whole square. Okay, cos theta minus I sin theta same as it is cos square theta minus I square sin square theta. I square is nothing but minus 1 and sin square theta same as it is. Okay, at the place of I square we are writing minus 1. Cos theta minus I sin theta, cos square theta minus into minus plus sin square theta is equals to cos theta minus I sin theta by 1. Cos square theta plus sin square theta is equals to 1. We know the formula. Okay, cos theta minus I sin theta is nothing but 1 by z value is cos theta minus I sin theta. Now we want z minus 1 by z. That value is cos theta plus I sin theta minus, and 1 by z value is cos theta minus I sin theta. 1 by z value we are writing in bracket because here minus is there. So cos theta plus I sin theta, multiply this minus inside minus cos theta, minus into minus plus I sin theta. Cos theta minus cos theta gets cancelled. I sin theta plus I sin theta is nothing but 2I sin theta. So z minus 1 by z value is 2I sin theta. Question number 9. If z is equals to x plus iy and mod z is equals to 1, then find the locus of z. Okay. Given z is equals to x plus iy, mod z is equals to 1, we have to find the equation of z. So here, mod z is equals to 1 given. Mod z is nothing but magnitude, that is under root x square plus I coefficient is y square, that is a square plus b square. So it is in the form of x and y, so we are writing x square plus y square is equals to 1. Here root is there, so squaring on both sides. So this square and roots gets cancelled. Here 1 square is nothing but 1. So x square plus y square is equals to 1. Therefore the locus of z is x square plus y square is equals to 1. Whenever there is a mod is there, mod z means mod of this. Okay, so x square plus y square under root x square plus y square we have to take. Okay. Next question number 10. Simplify I square, I, it is I, okay, I square, I power 4, I power 6 up to solution. Given I square, I power 4 plus I power 6 plus so on up to 2n plus 1 terms. Okay. I square, we can write I power 4 as I square whole square, 2 2s are 4. Okay. I square whole cube, that is 3 2s are 6 plus so on 2n plus 1 terms. Okay. We are writing in I square terms because we know the value of I square. I square is nothing but minus 1. So here minus 1 square minus 1 whole cube. Okay, minus 1 same as it is. Minus 1 whole square is nothing but plus 1. Minus 1 into minus 1 is plus 1. Here minus 1 whole cube, here odd number is there, so negative value will come. Next I minus 1 to the power 4 will come, so even, so 1 will become minus 1 plus 1 minus 1 plus 1, so on up to 2n plus 1 terms. So the first value is minus 1, so answer is minus 1. That is 2n plus 1 means odd value, so you will get minus 1 is the answer. Next question number 11. If under root 3 plus I whole to the power 100 is equal to 2 power 99 a plus ib, then show that a square plus b square is equals to 4. Solution. Root 3 plus I whole to the power 100 2 power 9 a plus ib. Here we will take the mod on both sides. Taking mod on both sides. Okay. So taking mod here. So mod is nothing but modulus. Here we have to find the magnitude, that is under root of root 3 whole square plus I coefficient is 1. So 1 square whole to the power 100 2 power 99. Here also mod is there, so under root of a square plus I coefficient is b, so b square. Okay. Now this square and root gets cancelled. 3 plus 1 is 4 to the power 100 2 power 99 same as it is. Okay. So root 4 is nothing but 2 2 power 100 2 power 99 under root a square plus b square. Here 2 power 99 and 2 power 100 gets cancelled. If you take this term, it will go in the denominator. So here 100 is there, here 99. So only 1 2 will left here is equals to under root a square plus b square. Again here root is there, so squaring on both sides. So 2 square is equals to under root a square plus b square whole square. This square and root gets cancelled. A square plus b square is equal to 2 square is nothing but 4. So hence proved. If z is equal to 2 minus 3i, then show that z square minus 4z plus 13 is equals to 0. We know the z value. We want z square value here. To substitute here, we want z square. Z is already there. Okay. So first we will find z square. Z is equals to 2 minus 3i. Okay. So z square will be taking square on both sides. 2 minus 3i whole square, it is in the form of a minus b whole square, that is nothing but a square plus b square minus 2ab. This is a and this is b. Okay, 2 square is 4 plus 3 square is 9 and I square is I square minus 2 2s are 4, 4 3s are 12, 12i. 4 minus because I square is nothing but minus 1. So plus into minus 9 minus 12i. 4 minus 9 is minus 5 minus 12i same as it is. So this is z square value. Now we will take LHS. we have to prove it as 0. So taking LHS, z square minus 4z plus 13. Z square value is minus 5 minus 12i minus 4 into z value is 2 minus 3i, which is already given, plus 13 same as it is. This one same as it is. Now multiply minus 4 inside minus 4 to the 8 minus into minus plus 4 3 the 12i plus 13. Okay, plus 12i minus 12i gets cancelled. Minus 5 and minus 8 is nothing but minus 13, and this one plus 13. Minus 13 plus 13 minus 12i plus 12i is equals to 0. Hence proved. Question number 13. Write the conjugate of the complex number 2 plus 5i into minus 4 plus 6i. We have to write the conjugate of this number. Okay. So, first multiply this because they both are in multiplication product form. Okay. Multiply 2 into this bracket plus 5i into this bracket. 2 into minus 4 plus 6i plus 5i into minus 4 plus 6i. 2 4 is 8 minus 8 plus 2 6 is 12i plus into minus 5 4 is 20i plus 5 6 is 30 I into I is I square. Okay, minus 8 minus 12i minus 20, that is minus 20 plus 12 is nothing but minus 8i, and I square is nothing but minus 1. So plus into minus 30. Here minus 30 and minus 8 is minus 38 and minus 8i. Conjugate is denoted by z bar minus 38, and this sign will change for conjugate. Imaginary part is there, so its sign is minus, so it will become plus in conjugate. Okay. Question number 14. Express the complex number minus root 3 plus I in modulus amplitude form. Modulus amplitude form is nothing but x plus iy is equals to r into cos theta plus I sin theta. For this we want theta and r value. Okay. See here. Our question is minus root 3 plus I. So it is in the form of x plus iy. X is minus root 3. Y is 1. Coefficient of I is 1. Okay. So the point is minus root 3 comma 1, which belongs to quadrant 2. See, in the first quadrant, this is first quadrant, second quadrant, third quadrant, fourth quadrant. Okay. X axis is positive and y axis is positive. So plus comma plus. Here x axis is negative and y axis is positive, so minus comma plus, minus comma plus. So second quadrant. Okay. Similarly, if both are negative, here minus will be there and here also minus, so minus comma minus. So this is second quadrant. For second quadrant, the formula is, if the point belongs to second quadrant, then theta is equals to pi plus tan inverse y by x. Pi plus tan inverse, this is x and this is y. So y is 1 by minus root 3. This minus will be multiplied here. Pi minus tan inverse of 1 by root 3. Pi minus tan inverse of 1 by root 3 is nothing but tan 30 degree. 30 can be written as pi by 6. Okay, so this tan inverse and tan gets cancelled. Pi minus pi by 6. Take LCM. LCM will be 6. 6 pi minus pi. 6 pi minus pi is nothing but 5 pi by 6. Okay, theta is 5 pi by 6. Now we want r. R formula is nothing but under root x square plus y square. X is minus root 3 whole square plus y is 1 square. The square and root gets cancelled and here it will become plus. So 3 plus 1 is 4, root 4 is 2. R is equals to 2. Okay, x plus iy is equals to r into cos theta plus I sin theta. R is 2, cos theta is 5 pi by 6 plus I sin 5 pi by 6 is the answer. Question number 15. If arc z1 plus arc z2 are pi by 5 and pi by 3 respectively, means arc z1 bar is this one and arc z2 is this one. Okay, then find arc z1 plus arc z2. Sorry, this is comma here. Okay, now given arc z1 bar is equals to pi by 5, we want arc z1. We have arc z1 bar value. Okay, we know one formula, arc z plus arc z bar is equals to 0. Okay, so arc z will be, take this here, it will become minus arc z bar. So arc z bar, z1 bar is pi by 5. So arc z1 will be minus arc z1 bar. Minus, this value is how much? Pi by 5. So minus pi by 5. Arc z1 will be minus pi by 5. Similarly, we want arc z2. It is already given arc z2 is equals to pi by 3. Now, arc z1 plus arc z2. We have to find arc z1 plus arc z2. Arc z1 is minus pi by 5 plus arc z2 is pi by 3. Now take LCM. 5 into 3 is 15. 3 will be multiplied here, minus 3 pi, and 5 will be multiplied here, 5 pi. 5 minus 3 is 2. 2 pi by 15 is the answer. Question number 16. Find the square root of 7 plus 24i. That is complex number square root. Okay. So 7 plus 24i, a plus ib. It is in the form of a plus ib. So a is 7 and b is 24. Okay. We have one formula for the square root. This is square root formula for the complex number. Plus or minus under root again a square plus b square plus a by 2 plus I under root again under root a square plus b square minus a by 2. Just we have to substitute a and b value in this formula. Okay. Under root a is nothing but 7 square plus 24 square plus 7 by 2 plus I under root same as it is. A square means 7 square plus 24 square minus 7 by 2. 7 square is 49 plus 576 plus 7. 24 square is 576. Same, 7 square is 49, 576 minus 7 by 2. Okay. Now add these two. You will get 625 plus 7. This 7 is outside the root, this small root. Okay. Here also 625 minus 7. We know the root of 625 is nothing but 25. Okay. Root of this value is 25 plus 7. And the root, this root is removed now because we know the value of root 625 is 25 plus 7 by 2 plus I under root, this value is 25 minus 7 by 2. Okay. 25 plus 7 is 32 by 2 plus I under root 25 minus 7 is 18 by 2. Now cancel 2 ones are 2 16s are 2 ones are 2 9s are. We know the root of 16 and 9. Root 16 is 4 plus I, root 9 is 3. Okay. Therefore, the root of 7 plus 24i is plus or minus 4 plus 3i. Question number 17. If x plus iy is equal to cis alpha into cis beta, find the value of x square plus y square. Okay. X plus iy is equals to cis alpha cis beta. Given x plus iy is equals to cis alpha is nothing but cos theta plus I sin theta. But here theta is alpha. So cos alpha plus I sin alpha. For cis beta, cos beta plus I sin beta. Okay. Now we will multiply cos alpha into cos beta, cos alpha into I sin beta, I sin alpha into cos beta, I sin alpha into I sin beta. Okay. So I into I square. First term whole bracket, first term, second term whole bracket, multiply. Okay. Now arranging the terms, real parts one side and imaginary parts one side. Imaginary means the term with I. Okay. Cos alpha plus cos beta, this I square is nothing but minus 1. So this will become minus sin alpha sin beta one side, plus taking I common here, cos alpha sin beta plus sin alpha cos beta. Okay. Cos alpha cos beta minus sin alpha sin beta is nothing but cos of alpha plus beta. Formula is there, plus I into sin of alpha plus beta. Okay. X plus iy is equals to cos alpha plus beta plus I sin alpha plus beta. So this is x value and this is y value, x plus iy. Okay. Now we want x square plus y square. So squaring x and y, cos square alpha plus beta, sin square alpha plus beta. We know the formula, cos square theta plus sin square theta is equals to 1. Here theta is alpha plus beta. Okay, both the thetas are same. So we can use this formula, cos square theta plus sin square theta is 1. So the value of x square plus y square is 1. Question number 18. Find the multiplicative inverse of 7 plus 24i. Multiplicative inverse of a plus ib, that is complex number. We have one formula, a by a square plus b square minus I b by a square plus b square. Just we have to substitute the value in this formula. Okay. A is 7 and b is 24. A by a square plus b square minus I by, into b by a square plus b square. Okay. A is 7 by 7 square plus 24 square minus I. B is 24 by 7 square plus 24 square. 7 by 7 square is 49. 24 square is 576 minus I. 24 by 7 square is 49 plus 24 square is 576. Denominators are same. Okay. 7 by, this is nothing but 625 minus I. 24 by 625. Okay. This is nothing but multiplicative inverse of 7 plus 24i. Question number 19. If z1 is equal to 2 comma minus 1, z2 is equal to 6 comma 3, then find z1 minus z2. Z1 is this and z2 is this. So z1 minus z2 will be 2 minus 6. We have to subtract from corresponding terms. 2 minus 6. Okay. That is first term. Then minus 1 minus 3. Okay. 2 minus 6 comma minus 1 minus 3. 2 minus 6 is nothing but minus 4. Minus 3 minus 1 is minus 4. So z1 minus z2 is minus 4 comma minus 4. Question number 20. If mod z minus 3 plus I is equals to 4, determine the locus of z. Locus is nothing but equation of z. So z is equals to x plus iy. Okay. Substituting z value, that is x plus iy, in this. X plus iy minus 3 plus I is equals to 4. Okay. Now writing real part one side and imaginary parts. X minus 3 plus taking I common from this I, y plus 1 is equals to 4. Since mod is here, so we know the formula for mod. Under root this part whole square plus coefficient of I, that is y plus 1 whole square, is equals to 4. Now root is there, so squaring on both sides. X minus 3 whole square plus y plus 1 whole square. The square and root gets cancelled, and 4 square, that is 16. Now x minus 3 whole square plus y plus 1 whole square. This is in the form of a minus b whole square, and this is a plus b whole square. So a square plus b square minus 2ab plus here also a plus b whole square, that is a square plus b square plus 2ab, okay, is equals to 16. X square, 3 square is 9, minus 2 3s are 6x, plus y square plus 1, 2 1s are 2 into y is equals to 16. X square plus y square minus 6x plus 2y. Now see the numbers. Plus 9 plus 1 is 10, and take this 16 here, it will become minus 16. So x square plus y square minus 6x plus 2y minus 6 is equals to 0 is the locus of z. Question number 21. Write the additive inverse of the complex number. Additive inverse is nothing but just changing the sign. If it is plus, write negative. If it is negative, write positive. Okay, see. The question is minus 6 comma 5 plus 10 comma minus 4. First we will simplify this number. Then after getting the answer, we will find the additive inverse. Okay. Here plus is there, so add these two values. Corresponding values will be added. Minus 6 plus 10 comma 5 plus minus 4. Okay. So minus 6 plus 10 is 4. 10 minus 6 is 4. Okay. 5 plus into minus 5 minus 4 is 1. We got the answer. Now we want additive inverse. Additive inverse of 4 comma 1 is nothing but minus 4 comma minus 1. Here plus 4 is there, so minus 4 plus 1 is this minus 1. Okay. Question number 22. If z1 is equal to 6 comma 3, z2 is equal to 2 comma minus 1, find z1 by z2. Okay. Z1 is 6 comma 3, so we will write in complex form 6 plus I3, that is 3i. Okay. Z2 is 2 comma minus 1, 2 plus minus 1i, that is minus I. Okay. So z1 z2, we want z1 by z2. 6 plus 3i by 2 minus I. Whenever there is a fraction in complex number, we have to rationalize. Okay, rationalizing the denominator. 6 plus 3i by 2 minus I, same as it is, into multiply and divide by the denominator but changing the middle sign. Is there divide by the denominator but changing the middle sign? If there is minus, so write plus. Okay, if there is plus, then write minus here. Okay, now multiply the numerator and denominator. 6 plus 3i into 2 plus I, 2 minus I into 2 plus I. Okay, 6 into whole bracket and 3i into whole brackets. So 6 2s are 12 plus 6 into I is 6i. 3 2s are 6, 6i plus 3 into I is I square. By this is in the form of a minus b into a plus b, that is nothing but a square minus b square. A is 2 and b is I. Okay, 12 plus 6i plus 6i is 12i plus I square value is minus 1. So 3 into minus 1 is minus 3. 12 minus 3 plus 12i. 12 minus 3 is nothing but 9 plus 12i by 2 square is 4 minus I square value is minus 1, minus into minus plus 1, that is 5. Now we will give the denominator separately. 9 by 5 plus 12i by 5. Okay, it is in the form of complex number. This is a plus ib So z1 by z2 is 9 by 5 comma 12 by 5. Again we are writing in point form as our question was in points. Okay, so the answer will also be in the point form. This is 9 by 5 comma 12 by 5. Question number 23. Find the real and imaginary part of a complex number a plus ib by a minus ib. Okay. Question: a plus ib by a minus ib, since this is a fraction and the complex number is also there, so rationalizing the denominator, multiply and divide by denominator by changing the sign. Here minus is there, so plus will be there. A plus ib by a plus ib. Okay, multiply the numerator and denominator. A plus ib into a plus ib by a minus ib into a plus ib. Okay, here a plus ib into a plus ib is nothing but a plus ib whole square formula you can apply. A plus b whole square formula, or directly you can multiply here. A into a is a square, a into b is ab, I ab. Here I b into a is iab plus I into I is I square, b into b is b square. Okay, in denominator a minus b into a plus b formula is there, so a square minus b square. A square minus, at the place of b we have ib, so ib whole square, that is I square into b square. A square minus I square is minus 1, so minus b square. ABI is nothing but 2ABI. Okay, by e square minus 1 into minus will become plus, so plus b square. Okay, a square minus b square plus 2ABI. Now giving this denominator separately, a square minus b square by a square plus b square plus I 2ab by a square plus b square. Okay, means we are writing real part and imaginary part separately. Real part is this one which has no I, a square minus b square by a plus b square, and the I part is imaginary part, and the imaginary part is 2ab by a square plus b square.